I'm going to show you how to use NEXO's NS-1. That's their proprietary acoustic modeling software. It comes with all of their audio systems pre-installed into it, ready to go, as well as all of Yamaha's professional products as well, because Yamaha owns NEXO, so they put it all in one. So to start things off, you need to download it. So if you jump over to your web browser, this link will be in the video description, so you can put that into your browser and bring this up. And you just scroll down here and you can download NS-1 for free. It's only on Windows, but once you get that downloaded and installed, you can open the software. And when you do, it's going to open up and look like this. This is just the default project that it opens with. First thing I'm going to do is I'm going to start a new project. And I've got a blank canvas here. And I'm going to go to Venue. I'm going to add a quadrangle. So this is going to allow me to put in a surface. This could be an audience plane. This could be like a wall or a floor or something like this. So I'm going to go ahead and drop that in. I get this window that allows me to set the details of how wide I want it to be, the length, etc., etc. And we'll go through all this in a bit more detail. But to start things off, we can give it a name. And I'm going to call this floor plan. And I want the mapping to be set to no audience, good for picture. So this is telling NS-1 that we don't want this surface to be an audience plane. We just want it to show up inside of our 3D view. And then we can actually apply a picture to it. And we're going to apply a floor plan to this. So we're going to start off by putting our floor plan and our section view of our venue into NS-1. So I click that, go apply, go OK. And I can also do the section view as well. So if I come in here and go venue, I want to add a wall for this. And what that does is it's already just put the surface in vertical. I could come in here and I could tilt this up if I wanted to, and I could make it a wall, but this is just a very quick way of going, boom, I want a wall. I'm going to call this section. I'm going to go apply, okay. And I'm just going to leave the sizes as they are right now. We're going to scale it to the size of the drawing once we get a little bit more info. So I'll show you the drawing that I'm going to use. Now, you could be using architectural floor plans that are in PDF form. You could be using anything that's got a scale on it. In my case, I found this online. I've got this DWG file and I've opened up in Autodesk's TrueView, and it gives me the plan and section view of a theater that some guy made for a university project. So it's perfect for our use case. And so what I'm going to start by doing is I'll just move down and look at the plan view itself. And I'm going to take a screenshot of this. And I'm going to do it from this corner up here down to this corner down here, which is going to give me all the necessary details of the actual venue itself. So I'm going to go ahead and press print screen. I'm going to come to the top corner here, and I'm going to try and be as precise as I can be. And I'm going to drop it down there, right? So I've just taken a screenshot of that. And what I could also do is I could move up and I could take a screenshot of our section view as well. And for this one, I'll probably take it from this corner down here to this corner up here. So let's go ahead and do that. If I select, yep, that corner, drag, and drop. Okay, I've taken a screenshot of both the floor plan and the section view. If I come back over to NS-1, I can click on my floor surface, right click, and go venue picture. I can open a file and I can navigate to local files on my computer. In this case, I'm inside my screenshots and I can see my plan view. So I'm going to drop that in and I'm going to hit apply and I'm going to hit OK. And then I'll double click on my section view. I'll right click on my section view and I'll do the same thing, only with the other picture, okay? I'm gonna apply that and I'm gonna go okay. Now you see that that is out of proportion. We can rotate the view by just left clicking and holding and dragging. So we can look around at it. And what I wanna do right off the bat is I wanna put the section view in the correct orientation. So I'm gonna go ahead and I'm gonna rotate this 90 degrees. Okay, so now I've got the section like so. And what I also want to do is, this is my 0 point for the X, Y, and Z. So this is the coordination point. And I want the front of the stage here on the floor plan, this part here where the stage bends around, I want that to be lined up with the X, Y, Z point, right? The 0 point. So to start with, I'm going to need to flip the image around. So if I right click, I can go view image and I can rotate at 180 degrees, go okay, and drop it, right? So now the stage is on the end where the XYZ point is going to be. And then in a little bit, what I'll do is I'll move this image back so the beginning of the stage lines up right with the XYZ point, okay? What I'll do with this for now is I'm going to go -20 on the y-axis, and I'm just going to move it out of the way so it's not in the way whilst I'm working on the floor plan. So to start with, we need to set the width and the length of the screenshot that we've got. And I can do that by taking a measurement inside of TrueView. So I go measure distance, and I can measure from this top corner down to this bottom corner. Now I'm working in meters, so I'm in the metric system, and it's telling me here that it is 30.5, right? So it's 30 meters, or 30.5 meters, sorry. Double click. So my width is 30.5. Okay, so that's fattened out. Now I need to get the length. And what I did was I took from this point and I went to this point, which will be 57.64. And we can probably just put 57.6, hit apply, hit OK. And there it is. That should be now correct. And I'm just going to double check. Yep, that value is correct. Cool. Now we'll move up here. And what I did with this one is I measured from this bottom line up to basically the top of there. So if I just, sorry, I'll click that again. I might zoom in a little bit so I'm making sure that I'm clicking the correct point. And we can we do that? Yes, we can. So that's 16.8. So let's come back over here, put the height as 16.8, hit OK. And then we'll zoom out, we'll move across just a little bit to there. We'll take a measurement and we'll take from that point to that point, and that is 61.7. 61.7. Okay, great. So we are almost there. So that should be now in proportion to how the drawing is. So now what we want to do is we want to move this drawing and we want to move it back so that the X, Y, and Z point lands right on the front of the stage there, okay? And if we go to the top view, can we see it? We can see it. It's a little bit hard to see. We can snap to different views here. So let's snap to the 3D view. I think this is the easiest way that we can see the X, Y, Z point. So I'll double click here. And I need to go in the X axis, and I probably need to go backwards, right? Yes, correct. So I think it's -21. We might just zoom in on this a little bit and see how close we are. We're sort of back on this red dotted line. We want to move it forward a little bit more so it's right on the stage lip. So let's go 21 point. Boom, there we go. So we've moved that in the X-axis 21.2 meters in the negative, so that we've sort of pushed it back, and now our starting point is right there. And that's going to really help us, because when we drop in speakers, the speakers are going to land on that 0 point, and then we're going to move them in relation to that 0 point. And if we don't have the front of our stage lined up, because typically everything's going to be symmetrical from that front of stage. So what that's going to allow us to do is it's going to allow us to drop a box in, move it up in the Z-axis, then move it wide on the Y-axis and sort of position it in place. And then once it's in place, we can mirror it and drop it over the other side. And it's just a very quick and easy way of working through the project. So finally, the last thing we're going to do is we're going to line up the section view to correspond as well. So we want this 0 point to be sort of where the floor meets the stage. Okay, so we want the floor level to be correct. We're going to build up for the stage and flat, and then for the rake seating we're going to build up as well. But we want this little section right at the front where there's no seats, we want that to be ground level, and then everything else is going to go positive from that front. So I'm going to line that up so that we're right at the beginning of the stage for that section as well, and right at the ground level. So we need to go down in the Z-axis, and we need to move in the Y-axis. And what I'm going to do to make this easier for us is I'm actually going to put it back in the center. So I'm going to move it back to the center, right? And then let's go, do we need to move positive or negative? We need to move positive. So let's go 7.2. Looks like it's lined up pretty good. And then let's go -2 meters, -2.1. maybe 2.2, right? And I could actually just go into TrueView and measure all this out and know exactly how much to move it if I wanted, but I'm just eyeballing it so you can kind of see that I'm just sort of going through an iterative process. And I think that's pretty good. I'm going to hit OK, zoom in there, and that's pretty good. Maybe it could come forward just a little bit more. So let's go 0.25, 0.23. That's getting a little bit like pedantic, but there we go. So we can see that the beginning of the rake seating and all of the seats are lining up nicely. We can also zoom out and we can see that this wall is lining up nicely there. The back wall lines up nicely here, so on and so forth. We can also see, now what I'm doing there is I'm holding shift, I'm clicking and I'm dragging to like pan it across, okay? And unfortunately, sorry, it's a little bit laggy. I'm not sure why. It doesn't always perform this badly. And we can see that that wall lines up nicely there too. So we've got a pretty accurate idea of our venue now. Everything seems to be lined up and I'm happy with that. So what I want to start doing now is I want to start actually drawing in the audience surfaces, and I want to draw in some important parts of the venue. So I'm going to draw in the stage. I'm going to draw in the proscenium so that I know, where I can and can't hang my speakers. And what this is going to do is it's basically going to just give us a visual cue, but it's not going to do anything. So NS1 does not do room acoustics. So it just does direct SPL mapping on a surface. It will factor in shadowing. So if we have like a speaker and then a surface and then another surface behind it, this front surface can block the back surface from getting any audio, right? But it doesn't take into account reflections or reverb or room acoustics in any way, okay? So it's just purely direct SPL mapping. So let's go ahead and start drawing in the venue sections now. So what I'll do to kick things off is I'm going to just show you how to drop in the 3 sort of basic surfaces and how to move them and manipulate them. And then I'm going to go ahead and I'm going to build the venue with as much detail as what I think is necessary. And I'll just fast forward that process once you already know it. And so you can watch me in fast time and see how I kind of just build it out. But you'll understand all the basic features that I'm using. So to kick things off again, what I'll do is I'll actually move the section again out of the way. I'll go -15, just move it across. And I'm going to draw, to start with, I'll draw this lower seating section here, right? And I'll draw that all in one go. Let's look at the top view. Let's move back by holding shift and dragging. I'm going to drop in a polygon, okay? So that is going to drop in and give us this window here. And this window has various points. And to kick things off, I'll just add more points and then you will understand what the points actually represent or what they do in a second. So I'll just hit apply, I'll hit OK. And so what we're looking at is like a rectangular surface. And if I hit this here, this allows me to move venue vertices. So when you're dealing with a polygon, you can actually grab the vertices and you can move them and you can change the shape of this. So it doesn't have to be a rectangle, okay? And what I'm going to do is I'm just going to automatically, I'll go back to the 3D view. And what I'm going to do is I'm going to give you a little pro tip. So when you're dealing with a floor plan and this surface, they're both set to be exactly 0 in the Z-axis. And so they overlap and it can be actually quite difficult to select the correct thing. So if I click in here, you'll notice that it's actually selecting the floor plan, but I want to select this geometry. So what I'll do is I'll double click the floor plan and I'm going to put it negative, so like basically 10 centimeters lower, so that now this is on top. And so I can always select it properly, right? And while I'm at it as well, I should give this a name. I should give this lower seating, right? So this is the seating closest to the stage and it's the lowest seating, so I'll just call it lower to keep track. And what I'll do is I'll put the listening plane, I'll put it actually on this corner. Even though seats shown to be a little bit further back, I'll sort of just use worst case scenario, let's say, okay? And I will work my way around. So let's say I'm going to put 0.2 here. And then I'll take 0.3 and maybe I'll put that in the middle because I I can't sort of bend these lines, right? They have to be straight lines, and it's more up to me how much of like a fine resolution, like if I wanted to put a point there and then a point there and then a point there, I get a more curved line, but it's probably not really necessary for what I'm doing. I'm getting the general shape of the audience, and that's what really matters right now. So I'm going to put that there, put 6 right up on the back corner there, like so. Cool. And I'll take this, put it about there, I reckon. And I'm going to have to draw, I'm going to have to drop in a bunch more vertices, right? So I want 2 more points. So double click this, come to the end, add, hit apply, hit OK. Got number 9, I can drop it there. I got number 10, I can drop it there. Okay, so that is how you can move around and do it by mouse. You can also just drop in your coordinate information. You can write in exactly what you would like. And we're going to do that for the Z-axis, okay? And so if I hit OK here, what I might do, which is probably going to be the easiest way to get a sense of how high this is. Actually, it may not be that easy to do. Let's see whether we can do it. Because I don't have like an intersecting line. Like if I click that, can I then click and measure up? No, it's not going to let me do it quite the way I want. If I click that, see if I measure down, I'm not really going to know exactly what intersects there. Oh, yes, I may. There we go. Boom. Nice. So is that telling me that that's 12 meters? I don't think that's 12 meters. Maybe it will be easier just to use the section view. So I'll hit here, I'll come here and I'll go onto a 3D view. I can zoom around. And what I could do is I could put this section right smack bang back in the middle, hit apply, hit OK. And I think it was, so that'll be vertices number 9, that'll be 8, that'll be 7, right? So if I come here and I set a value on the Z height, if I go 1.5 meters, can't see it, 1.5 meters. There we go. I can see that. I got the wrong one. So that's almost right. It looks pretty bang on, actually. Let's say that that's right. 1.5. Apply. And then, oh, we've got 1.5 there. Hit apply. Okay, so that means that corner there is the last one we need to lift up. We'll hit 1.5, hit apply, hit OK. Cool, and that looks like it's pretty good. Let's go left view. Yeah, okay, so that back section looks like it's bang on, and the surface is cutting straight through the plane. Now you'll notice that that's not actually at ear height. And so how we do that is we sit the venue plane at like ground height, and then inside of here, we say that the audience ear level is at seated height or standing, or if it's actually to map onto that surface itself, okay? So in this case, we're seated, so it's gonna go 1.2 meters above that surface when it's doing its mapping. Okay, so that is how we would do a polygon, and move it around. We know how to do a quadrangle already, but just some interesting little things. You can put a slope on it. So if you know that there's an incline, you could say that there's a 5 meter incline. So that's useful. You can rotate your surface, and then obviously you can move it around. So there's not too much else to show you in there. You know how to change the mapping, blah, blah, blah. So I'm not going to go into the quadrangle any further. Sorry. No, I did call it the correct name, quadrangle. And then wall is going to be pretty straightforward. So these are your main things. This is the same again, right? Nothing special. So what I'm going to do now is I'm going to fast forward what I'm doing, and I'm going to build the rest of the surface at the venue, right? And so whilst I'm doing that, you'll notice that this surface, the one I draw here and the one I draw back here, they're all going to be listening surfaces. And then everything else that I draw are just going to be the surface that's appropriate for a picture, right? So it's just going to show up, but we're not going to map SPL on it. Okay, well, unfortunately, it stopped recording, but I have gone ahead and drawn everything anyway, and it's just been done off camera. And whilst I was doing that, there are a couple of things or features that I use that I'm going to need to point out to you. So if I delete the surface, for example, if I click on this one, I can go Control D, and I can flip it across an axis. In this case, I want to flip it across the x-axis. So I'm going to call this side left, right? Give it a name, hit OK, and it copies across, right? So side left and wall right. And another thing that I used here was I used the venue positions. This gives me a list of all of the things that I've drawn in as a venue plane. And I can see that V8 has been drawn in here, which doesn't have a name, so I can edit it. I can give it a name, so this is, all right, give it a name, get it OK. And I can see that I've also got an audience section here that's disabled. So I can actually deactivate them so I don't see them. I'm going to turn it on so that it's seated. And boom, there's my middle seating section, okay? So now I've got all of my parts of the audience drawn in, and if I look on the side view, like everything lines up nicely as I checked before as I was going. And now what I'm going to do is I might just deactivate the section view, so we'll turn that off for now, and also the floor plan. So we could keep these details if we wanted, but now we've got the, wow, look, now NS1's running way faster all of a sudden. Apparently, those images took some heavy lifting. So here we go. We've got our base model in, and we can start working from here with putting a sound system in. So now we're going to start putting in some sound sources and looking at how they behave and how we can move them and what we can do. So now let's add a speaker. And I'm going to start off with a point source speaker to begin with, and then we will move to a line source. We're going to start, let's say, with the P15. So this is a 15-inch point source loudspeaker box. And if I double click on it, I can create a new system, and I can drop it in a number of ways. So I can put it in as a flow-in combination, a stacked combination, or a single unit. And so the combinations would be a point source box with a subwoofer, companion subwoofer. So for the P15, it'd be the L18 low frequency subwoofer. I'm going to use a flow-in combination. So if I hit that, then I get this window here, and this allows me to name it. So let's just go front of house, and we'll just say center. We'll just keep it in the center for now. We could give it some info, we could give it some color, and then we could zone it, and we'll look at what that does in a little bit. It's just kind of managing our project and keeping things organized, and we can set that up. What we want to pay attention to is here we have position. We have like rotations of it if we need to move it, like point it up and down, whatever. We have the electronic side of things. So if we want to mute the system, if we want to run it as an active box, so biamped rather than just passive using the passive crossover, we can do that, and that'll give us a little bit more SPL with these particular boxes. We can also attenuate, and we can add a delay to it to timeline. So let's just throw it in as it is and hit OK. And you can see there that our point source box is dropped in with a subwoofer mounted above it, and it's dropped it right on that 111 point, right? So we can then start manipulating it. We can move it around, right? So we could say, okay, I want it to be 1 meter inside the room, and I want it to be like at a 5 meter height. Boom, there it is, it moves. Great, cool. If I come to this tab here, then we get more controls. So we get configuration. So this allows us to change the configuration. So for all of the P15 configurations, we've got P15 plus L18, or we've got P15 plus 2 L18s, right? So we can do it with a cluster mounting bracket with the box angled below, and we can adjust the angle of the box below the subs. And we can do that for P18s, P12s. They all come with a companion subwoofer, and we can adjust the box angle. So we'll just keep ours on single sub. And here we can change the angle of the box below. So we can add angle as required. We can change the dispersion flange inside of the P15. So we can go 90 by 40. So that's 90 in the vertical, 40 in the horizontal. Or we could go 40 in the vertical, 90 in the horizontal, right? And it gives us a nice visual depiction of the type of coverage that we're going to get. Or we could use like a PS flange. So narrow at the top, wide at the bottom for kind of throwing out over a distance. And then we've just got a symmetrical 60 by 60. Cool. So these are all of the different flange types that we could get for the P15. And here we can change the crossover. So we could either have and these are all based on the presets and the NX amps. So 32 Hertz to 60 or whatever else. And then we can change the box to correspond as well. We'll just leave it all on default for now. So let's say a negative 15 degree angle, and we'll set it to the PS flange. We'll hit OK. And we can see with the green laser beam where the speaker is actually being aimed, right? And so we won't do any SPL mapping now. We just wanted to look at how we would drop in a point source box and configure it. Let's now take a look at the line source. Okay, so the same process again. We want to drop in a line array. So we'll select a line array system. So I'm going to use the GOM12 and I'm going to use the 10 degree angle box. Double click that. I can fly it vertically, I could ground stack it, or I could put in a single unit if I just wanted to do like a front fill with a single unit or something like that. I'm going to do a flow-in vertical. And on this one, we get a different view, right? So we still get this GPS information that allows us to do all of the same things on the previous one. But here we get a different view. We get this side view. And what I'll do, I'll make this full screen. And we can see the boxes and we can see the trim height that they're hung at. So at the moment it's about 8 meters. Let's bring that down to, let's say 6.5 meters. Okay. So hit OK. That's probably too low actually. Let's go back to 7. Yeah. When you're actually looking at the perspective of the room, that makes sense. And this should probably come forward, say, that's not going to bring it forward. We should bring this forward a bit because, so Nexo doesn't like it when you leave a box with a zero value, with no value. You need to put a 0 in there, right? So, okay, so that brings it forward well enough. Maybe that's sort of approximately where we would hang it in terms of the X coordinate. And so we can start aiming our box, right? So this gives us all the control for aiming our box. And we can see our 3 venue planes. This is the front audience row, this is the middle audience row, and this is the rear audience row. And here we're seeing dB MIF, and we're seeing volume mapped across this venue plane, okay? And this is mid-range frequencies, okay? So this is from 2 kilohertz to 8 kilohertz. And it's giving us sort of the average SPL volume over the surface area that we've got there. In this section here, we can see the total number of array elements we've got. So we've got 5 of the 10 degree boxes, and then we've got 1 of the 20 degree boxes. And we can see the interbox angles here. We can see the horizontal coverage flanges, because we can fit flanges into these boxes to change our horizontal coverage. So we can do sort of wider at the bottom and then narrower at the top. And we could also mute boxes if, for whatever reason, we were doing that. Now, to kick things off, we're sort of shooting right over everybody's heads with these top few boxes. So I'm going to tilt this down a little bit, and then I'm just going to show you how you can kind of roughly aim a line array using Nexo's software, because there's no auto splay, okay? So if we put a 5 degree tilt on this, and then we jump back in, that's too much, okay? So let's go. I want a little bit of overshoot. Let's say negative 2 degrees is going to be good to give us a bit of overshoot, okay? So the top box overshooting a bit. The next box we could add, say, a 1 degree angle, and that is more or less going to be aimed right at our back audience. And I'm going to do like a progressive splay. So I'm going to go 2 degrees, and then I'm probably going to go to like 3. And I'm going to try and get sort of equal distance between the between the amount of distance that the boxes are covering, right? And this is going to give me quite a smooth coverage. And these additional boxes that I've got shooting up the back are just going to make sure that this rear audience are getting enough volume, okay? Because if they weren't there, if I had this box aimed right at the top, we would suffer in terms of SPL that would be available to the back rows, okay? And so next we'll go, say, 5 degrees. Yep, okay. And then if we want to evenly cover this, maybe we would drop an additional box on there, another 20-degree box, and we could either go 16 or we could go 20, right? And if we went and dropped another box again, we would be blasting the front audience quite a lot, which maybe will be okay. We'll put a 20-degree flange on the bottom 2 boxes just to make sure that we're getting a good amount of horizontal coverage there. And we've got a fairly flat response across here, right? And so if I started then tilting the angle of the array, the total angle of the array, if I go up, we can see it changing on the fly. So if I get back to 2, that's pretty flat across the board. If I tilt it down even more, you'll note that, yeah, it's pretty flat and even actually, but we're starting to lose a bit of SPL in the back audience row, which may or may not be what we want. And you'll see that now that we've got that box aimed right at the top part of that rear audience, we're losing SPL. And that's why overshoot is important, right? We overshoot the box a bit, we get more SPL. You may say to me, that's going to cause reflections. And you're right, it will cause a reflection. We're hoping that there's some kind of acoustic absorption behind the rear audience. Let's assume that we have a little bit of influence and we can get them to put up some acoustic treatment, because they should be doing that anyway. The sound system is only going to sound as good as the room itself. So anyway, that's quite flat and I'm fairly happy with it. And if we jump over to dBA, we're even flatter with dBA. Okay, so we've got pretty damn good coverage here. And so I'll go, okay, yep, that's good. And then what I could do now is I could set my position on the y-axis. I could say, okay, 6 meters, yep, that maybe is pretty good. Maybe we don't have sightline issues here. Maybe we're allowed to hang it right where it is, right? We're assuming for the purpose of the exercise. And then here, we're also able to say where we want the high frequency driver to be. Is this going to be on the right side or the left side, right? And so we're on the right, so I'll put it on the right. I'm going to flip this across the axis, right? So now I've duplicated it, and this one can be left, okay? So we've made a pretty rough line array here, and I want to show you the mapping features before we move on and complete the system design. So if we want to map SPL onto these venue planes, we open up the contour window and we open contour control form, or we open up this, we click on this contours button and it opens up all the settings to map the SPL. Now, the first thing we've got up here is the type of analysis we want to do. So if we do direct sound, then we're mapping direct sound on the surfaces, but we could also look at time coherency, so time delay between sources for time alignment. Here we've got the test signals. So we can either use pink noise or pink noise following the IEC 268 standard. So pink noise is going to be obviously like a broadband. It's from 31.5 or 32 hertz to 16 kilohertz, and it's got a crest factor of 6 dB. Okay. Here we can select whether we're going to look at like a broadband response or frequency bands, and we can look at like specific single frequencies, or we can look at a third octave band or a full octave band around the 1 kilohertz point, right? So we have those controls there for looking at quite fine details. And then for more broadband details, we're able to set either a dB, A, C, B, like a weighting, or we can look at a broadband, but sort of like specific to mid-range frequencies or low frequencies. So we've got dB in, so 2 kilohertz to 8 kilohertz. This is good for analyzing like intelligibility and whether you've got good coverage of your audience for like a good clear vocal. And then you've got dBLF, which is obviously going to give you a good understanding of your low frequency performance. Here we've got the density. So this is kind of like a form of resolution. So when it does the mapping, it's going to dictate how many points in an octave band it's actually looking at. So if we're just 1 point per octave, then for every octave we have, we're only looking at like one frequency at any given octave. 3 is obviously going to look at 3 different frequencies within each octave band, and then 6 is the highest resolution, and that's going to give us 6 points. And so when we use these higher resolution, when we're using higher resolution, it takes longer for the computation to take place, right? So when we're just doing a brief design, we can go 3 points per octave, and that's just a good default to start with. Here, this gives us the scaling for our SPL meter. So if I just hit 140 dB and hit start, you see it's going to give us an SPL meter on the side here. And so we can set it to kind of whatever maximum setting we would like, or we could just leave it on auto and it sort of auto scales itself, right? And so that's up to you to decide like whether you want it to be fixed at a certain value, or whether you just want it to automatically figure it out. Step is going to give us, for every change of color, how many dBs is that going to represent. So in this case, it's 3 dB for every color change, but we could do 1 dB per color change if we wanted sort of finer resolution, or even broader resolution, we go to 6 dB, right? So normally I just leave that on 3 dB. Resolution, this is how many points it's going to map across your venue surface. And so obviously if you've got a lower setting, it's going to map more points. If you've got a higher setting, it's going to map more sparsely. And so by default, NS1 is just going to look at the venue surface that you've got, and it's going to automatically come up with like a default setting, which in our case is 1.5. But you can go lower. There are limits to how low you can go though. So it usually doesn't let you go between like 0.4 or 0.5. That's kind of like the lowest limits. And obviously the finer the resolution, the longer it's actually going to take for the SPL mapping to occur. So yeah, if you've got a slow computer, it will take longer. And here we can set some headroom. So for example, if we want to apply 6 dB of headroom, then it's sort of just attenuating the system so that your max SPL is no longer like the full maximum. There's a bit of headroom above that. Shadowing is going to allow us to, if we've got our source and then we've got like a balcony that's blocking a lower seating area, the shadowing will show that the balcony is going to block the sound, so that we can figure out whether we need a delay system or something like this. Or if we've got like a pillar that we've drawn in the room because maybe we thought it was a good idea to have that sort of detail, the pillar can actually shadow the audience behind it, so you can see, oh, this pillar is interfering with the coverage, and et cetera, et cetera. And then transparency, that allows you to change the transparency of the venue plane. So if you want to see through that and see the surface below, like the floor plane below, you can do that if you like. And so what I've got here, 3 points per octave, the default resolution, I usually put 3 dB of headroom, 3 dB step, I just let it auto resolute, and then put it on dBA. This is kind of my default settings for when I'm just quickly getting an idea of a system. And if we look at this one in particular, you'll see that the coverage isn't great right up the front. But it's sort of giving us the impression that this system is giving okay coverage. If we flip it over to dBMIF and we hit go, it's going to tell us that you can't use pink noise plus IEC for the dBMIF or dBLF for whatever reason. So it will just use regular pink noise. So we'll just go, okay, whatever. It'll run. We can close that. You can see in the middle, we're actually getting quite a bit of a drop in coverage, right? So we would potentially either just need to reapproach our design completely, or we put a center fill or something like this to get coverage in here. We can see the coverage for these 2 rows is looking pretty good actually. But yeah, our front audience here, it's getting quite hot right under the arrays, as you'd expect. And then there's not a lot of coverage on the front row, so we'd probably want to put in a front fill. And so that's how Nexo's mapping works. I think what we should do now is we should make a full system. And I'm going to do that, but I'll do it quite quickly. I'll speed up the footage. And so what I'm going to do is I'm going to put in some front fill. I'll reposition my arrays. I'll put a center fill in. I'll put in some subwoofers. And then once all of that's in place, I'm going to show you some of the final features. I'm going to then align the system properly so that everything's sort of volume matched and we get like a very even coverage across the audience. And then we'll look at some of the subwoofer features and a little bit more like line array features as well, because there's some stuff I want to show you there. So I'll fast forward the footage, I'll build a system, we'll talk about it, and then we'll massage it and get it to a finished point. Okay, so I've got a completed system in here with all the elements that I think are necessary for, this one. I want to show you a few things first. So if we come up here to view, we can change a couple things here. So see the green laser beams? We can activate or deactivate them here in the view. We can turn the contours off if we don't want to see them for whatever reason. We can also set radiation beams, so we can see the radiating sort of pattern of our systems. Similar to the laser beams, it's just for the line array boxes. Obviously, you see all of the beams for each cabinet. Show coverage areas, intersection lines. There's a bunch of other things here. Labels for each part of the system, and labels for the speakers as well. So you can turn all that on and off here. I turn it off because it's a little bit messy sometimes. It can be good to identify, left, right, PA, that sort of thing, if you need it. What I also want to show you is we looked at the venue positions before, and we can just come in here and we can just check. Everything's labeled very clearly. We can see what everything is, so that's nice. We don't really need to do anything in here because, maybe sometimes you'll share your project file with somebody. And so it's useful to make sure that everything's sort of tidy and set up nicely. If we take a look at our speaker systems, we can see that this is not so tidy. Things are not labeled very well. And we could just make this look quite a lot nicer. So we can also set up speaker zones. Okay, so we could hit a new zone and we could say front of house, right? And then we could go new zone subwoofers, new zone front fill, And we'll put the center speaker in there, right? So we've got all of that. Now what we can do is we can put the systems into their respective zones. So this is going to be front of house, front of house. We'll put the P15 in the front of house as well. P8 is going to be front fill, right, so on and so forth. And then we're going to have subwoofers and subwoofers. Now that window, the venue plane window, speaker position window, can be really useful because in here we can actually change the position of things on the fly. We don't have to open up that window. And so we could have this, say, on a secondary screen or somewhere out of the way so we can see what we're doing. And we can make adjustments here. So if we wanted to change the angle of this box, we could do it and then hit play to re-update the mapping. And we can do things on the fly. We don't have to keep diving in and out of the folders, which is super nice. We can also attenuate systems here as well, which is cool. And if we come back over to the speaker zones, here now we can see that our speakers have been put inside of the groups, right, that we set up. And we can actually attenuate the system all at once if we would like. So we can go into individual systems and add attenuation, right? Or we could just do the entire system itself, which can be quite useful too. So let's label everything though, because my labels are not good. So this is going to be front of house, left, front of house left, front of house right. Cool. We can give each thing its own color as well. So we could say, okay, well, I want my front of house to be this aqua color. And maybe this could be helpful because you're exporting a screenshot of your system to somebody. And you could say front of house, and then you could just put in brackets aqua colored speakers, you know, whatever, just to help people understand your system design. So this could be the same color, right? We could make our subs blue. We need to give the subs name as well. So actually I should have done that. Subwoofer, left, right, left. Give it a color, blue. And I also actually want to bring them in closer to each other, right? Because they don't have to be quite so far apart. Let's do that. Cool, nice. And you can see I've got that bottom cabinet in cardioid for the subs, just FYI. And then let's call this front fill, and I'll call it 4 because I'll count 1, 2, 3, 4. Right? I just count sort of left to right. Makes sense to me. Front fill 1. I should be giving this color as well. Sorry, front fill 2. And I should have gave it a color as well. Okay, what color do we want? Let's keep it sort of in line with the others. Let's give this one a navy, like a dark blue. So we're going with a blue theme. That's working for me. This is going to be front. That's not how you spell it. Front. That's also not how you spell it. 3. Well, where did I get my keyboard license? I'm now going to set that to blue, front fill 4. Nice. Okay, so everything's nicely color-coded. Let's go back to this MIF calculation to start with. And I just want to quickly jump into the line array and show you something quickly, and then we're going to balance our system a little bit better. So if I jump in here, something I didn't show you earlier was that we can see the SPL contour of the system. So we can right-click, we can show SPL contour. And this shows us the actual, SPL as it's hitting the surface and as it's radiating out of the system itself. And this is very nice because not all software shows this kind of level of detail. So this is pretty cool. And it can help you when you're aiming your line array so that if you're putting like really dramatic gaps in your line array, or if you're pointing lots of elements all in the same area, you're going to see that you're going to get like really sharp, like lobes and that kind of thing from the line array that you actually probably don't want. So this just gives you another, well, not probably, you absolutely wouldn't want. So it just gives you a nice extra level of detail. And you can also insert microphone positions, which can be cool because then you can get a frequency response curve. And so, for example, we could grab our microphone here and we can say, okay, well, what's it sound like right up in the rear audience, right? And then we could put another microphone in and we could put that right sort of up front. And then we could put one, boom, and we could put it, say, here, right? And we get the overall frequency response. Because we haven't put subwoofers inside of the array, we don't see the response from the subwoofers. And so that's super nice too, okay? Because we can then export this and send it to our end user to show them, you know, if we've got a really good response, you know, you want to brag about it. So that's some more detail on the line array side of things. For the subwoofer, you can do the same thing with the subwoofer array. You can actually go right click, show SPL contour, and we can zoom out a little bit. If I just turn that, there we go. You can see it also changes based on which parts of the subwoofer array are set to cardioid, right? So if I want to change some boxes to be in cardioid configuration, it changes the mapping that we can see. And we're looking at 31 hertz, right? So keep that in mind. You can change that to be like 63 hertz, and you can see, yeah, the rejection. So if we wanted our stage to have less sub frequencies on it, we could just create a cardioid array. And so in my case, the bottom box on both sides of my subwoofer array is going to be in cardioid. Now, another thing that we could choose to do, I'll just go back to this one for whatever reason, I could have done it on that one. We're able to do this with horizontal arrays as well as vertical arrays, but we can also beam steer, right? So we can start applying a steering angle. Let's go down. So if we wanted to tilt this array, subwoofer array, so that it's firing downwards, we can add an electronic delay to the subwoofers in order to attempt to beam steer the system, okay? And so we can do that there. I'm not going to do it in my case. I'm just going to leave it like so. Applying delay to the system will start smearing it a little bit, right? So it's not going to be, that's not going to be ideal. I mean, it can help with systems, so your mileage will vary, but I'm just not going to apply it to the system in this case, right? So that is everything I think that I wanted to show you in regards to the subwoofer arrays and the line arrays. So if we run this mapping, we're looking at the MIF response. We can open up, can we do it over the zone? Yes, we can. We can attenuate the whole zone. So let's say we'll pull the front fills down -3. And NS1's a bit strange. It doesn't allow you to put negative values. So if we put 3, then it means it's going to drop at 3 dB, right? I'll rerun that calculation and boom, there we go. Immediately that is way more even across the audience. If I put that back to 0, run that again, we're getting hot in the front, right? So just pulling the front fills back, say 3 dB, this smooths it out, and now we're getting a very even volume across the entire audience plane. If I then look at the histogram, remember this is for the mid-range frequencies, and we have a very nice response here, okay? So the minimum SPL value is 102 dB. The maximum is 106.7, our average, and then our standard deviation, which is under 1 dB. So for mid-range, to have that under 1 dB is awesome. Right? This will be a great system. Now let's take a look at the dBA, right? I'll look at the low frequencies last. dBA, okay, it's not quite as even in its coverage by the look of it. But if we take a look at our mapping, our histogram, we can see that we are pretty much within plus or minus 3 dB, right? We're just a little bit more than that. And our standard deviation is just a little bit higher. And so this design, if we wanted to improve it a little bit, we could maybe try and get a little bit more energy on the back row because it looks a bit light up here. But, you know, as you get further away from PA, it does get quieter. And I think that to have the back rows be a bit softer, it's not the end of the world, and it's not going to be out of that more or less plus or minus 3 dB, which is our standard target that we try to aim for. Now, subs are going to be a different kettle of fish completely. Let's put it on low frequency. Let's run it. And we can see that because the arrays are creating frequencies down to sort of lower limits, there will be a bit of comb filtering between the subwoofers and the arrays. But if we were to, if we click on a source and go Control-Shift-M, we can mute a source. And so if we mute all of the other sources apart from the subwoofers and we run the calculation just on the subwoofers isolated, of course this isn't taking into consideration the room acoustics, but we can get an idea of how even the coverage is for the subwoofers across this audience plane. And it's actually really good. It's plus or minus 6 dB, right? And that's really hard to achieve with subwoofers, especially if they're ground stacked, right? Because the front audience row is going to get smashed and everybody else is up the back is going to, you know, not have it as loud. And so if we fly them like we have, of course we have to timeline it to the rest of the system, but this gives us a really even and smooth response. Cool. So I'm really happy with that. And now I'll just turn the rest of the system back on again. And so overall, this is a pretty good result. And now I've got everything nicely named and labeled. So if I distributed this, everybody or people would be able to kind of understand what I've done. I didn't label these, so let's just... Right, we should always be giving really tidy files to people. So boom, there it all is. Really nice. Now, if we want to send the system to somebody for like giving them a rigging guide or something like this, we can export this project and NS1's going to generate a report for us, right? Can we flip through the pages here? Yes, we can. So yeah, you get a summary of the system. It gives you all of the box angles, the rigging information, etc., etc. So that can be really nice for spitting all of that out and giving to somebody who's going to install the system, or somebody who's just kind of looking at the system and determining whether it's the right fit for their venue. And so I think that that's a pretty exhaustive overview of NS1. I'm sure there's some features that I've forgotten, but I hope that you really enjoyed this video. If you have any questions, feel free to ask them down below. And I will see you in another video very soon. Thank you. Cheers.